We're doing a very important sum. Let's see the sum first. It says that prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding medians. Now here when we talk about two similar triangles, obviously we need to have two triangles which are similar to each other. So we have a triangle ABC and a triangle PQR which are similar to each other given to us. So we write that in the given, triangle ABC similar to triangle PQR, right? It says that it is equal, you have to prove that the ratio of the areas of two similar triangles is equal to the square of the ratio of the corresponding medians. Now when we say median, what do you mean by median? We know that median is nothing but a line segment drawn from a vertex of a triangle to the midpoint of its opposite side. So that means when I say AD is a median, what do I mean by that? I mean to say that BD is equal to DC, right? That is what we can say about BD and DC. We know that they are equal. That means I can say that BD is equal to DC is equal to half of BC. Same way, and the other triangle PQR, when we say that PS is the median, so what can we say about QS and SR, right? We can say that QS is equal to SR, and then we can write that QS is equal to SR is equal to half of QR. So this is what we have in the given, that triangle ABC is similar to triangle PQR and AD and PS are the corresponding medians. Now when we look at the proof, the proof says that we need to prove that the ratio of the areas of two similar triangles, that means we have to prove the area of triangle ABC upon area of triangle PQR is equal to, that is equal to the square of the ratio of their corresponding medians. Now when we say corresponding medians, what are they? AD and PS. That means we are saying that it is equal to AD square upon PS square. So we have the given and the proof ready. Now let's start thinking, how will we get this? If you look at the sum, in the given information, we have one information given to us that triangle ABC and triangle PQR are similar. The reason is given. And in this sum, we are talking about two triangles which are similar, and we are talking about, in the proof, we want the ratio of their areas. So when we talk about two triangles which are similar, and when we talk about their area ratio, that means we are talking about one theorem, that is what we have learned, that the ratio of the areas of two similar triangles is equal to the ratio of the squares of their corresponding sides. Beautiful. That means we can write area of triangle ABC upon area of triangle PQR is equal to AB square upon PQ square. And let's say we mark this as our result number 1. Beautiful. So we reached here. Now let's look at what we got in result number 1 and compare that with the proof. If you see the proof left hand side and what we got in this statement number 1, you see that the left hand sides are same. So now we need not worry about the left hand side, it's already over. Now we need to focus on the right hand side. If we compare the right hand side of the proof and what we got in statement number 1, we want AD square upon PS square, right? And actually what we have got is AB square upon PQ square. So that means we somehow need to get this right hand side is equal. So the squares are there, we just need to get those ratios equal, that is AD upon PS is equal to AB upon PQ. That means if we have to prove this, we need to get AB upon PQ is equal to AD upon PS. Now remember, when we want these two ratios to be equal, there's one thing, the numerator should form one triangle and the denominator should form another triangle. Then we can get those two triangles similar and we can get these ratios equal. So now let's check, let's look at the numerator, AB and AD. Does AB and AD form one triangle? Yes or no? Yes, it forms one triangle. Which triangle? That triangle is nothing but it is triangle ABD. Beautiful. Now let's look at the denominator. Does PQ and PS form one triangle? Yes, they form one triangle, right? Which one? It's triangle PQS. That means if you want these ratios to be equal, we somehow need to prove that triangle ABD is similar to triangle PQS. The moment we get this, we'll get the sum. We'll get the ratios equal and we can substitute that and get the right hand side of the proof done. So now somehow we need to get these two triangles to be similar. Which one? Triangle ABD and triangle PQS, right? And when we focus on these two triangles, triangle ABD and triangle PQS, For that, we need to check what information can we gather. We have an information given in the sum that triangle ABC is similar to triangle PQR. From that, can we obtain something? We can get the ratio of the corresponding sides there. So we can write AB upon PQ. This ratio is equal to, we take it as equal to BC upon QR. This may help us in the sum, right? So we write that AB upon PQ is equal to BC upon QR. This is what we got, and this we mark it as result number 2. The reason is corresponding sides of similar triangles. But we want now BC. AB upon PQ which we got, that is a part of these two triangles which we want. But BC and QR, they do not belong to these two triangles which we want, that is triangle ABD and triangle PQS. That means somehow we need to create a relation between BC and BD. Is it possible? Observe that what we have got already. If you see what we have written, that BD is equal to DC is equal to half of BC. From that we know that BD is nothing but half of BC. So we can say BC is nothing but it is twice of BD. Wasn't that easy, right? And that's our statement number 3. Now this is something which we can substitute there in statement number 2, right? Now the next one. The same way I need to get that I don't want QR, right? Rather, I don't want QR, I want QS there. So I need to create a relation between QR and QS. Is it possible? Yes, the same way as we did just now in statement number 3, we're going to do that. That means we can say that QS is half of QR. So we're going to write that QS is equal to half of QR. Now if QS is half of QR, now take that 2 there. So we'll get QR is nothing but it is equal to twice of QS. So we get QR is twice of QS, and the reason is nothing but since we know that S is the midpoint of that side QR. Now understand, students. So this is where we reached. Now these two things of result number 3 and result number 4 we can substitute in 2, and this will help us to prove those two triangles, that is triangle ABD and triangle PQS, to be similar. I know you can do it. I'm going to leave it here and I want you to prove it further. I'll be back.